Hello everyone, this is my video submission for SIT232 SimpleReaction controller. Within this task, we had to create a SimpleReaction machine, and for that we have been given four resource files. There is a GUI file, the random generator, the control for reaction machine, the code for reaction machine, and the controller class as well. And what was required was that a SimpleReaction controller would so the requirement of the task is that a simple reaction controller has to be made that would switch the states for the machine with accordance to the inputs that the user enters. And so that's the thing. So first of all, what I will just do is give a look for the UML diagram that I use in order to create this program. So yeah, I'll just get into my submission. So yeah. This is the UML diagram that I had used. So you can say that the machine is basically sitting in idle state and it's waiting for the coin. When the coin is inserted, it's going to move to the waiting state where the machine is basically waiting for the user to enter go button or the stop button. And if it's pressed too early, it's considered as cheating. So within the waiting stage, if the button is pressed, it will be considered as cheating. And then it after the waiting stage is over, the user press the go stop button and it goes into the waiting for reaction state, and random delay expires and the user and the machine enters the measuring time state. So after the reaction from the user, the machine basically measures the time, and then basically that time is displayed on the screen. After about 3 seconds again, the machine is basically waiting for the coin again. So yeah, so your machine waits for the user to enter the coin and it gets to the idle state again. So this is the whole program that I've used. Yeah, one more thing. Let's say if again, as you guys can see, if button is pressed too early, it's gonna get back to the waiting stage, that is the idle stage. So yeah, this is the UML diagram that I've used. And now what I will do is switch to the program that I created with the help of this diagram as well. Share simple reaction machine. So yeah, so this is the code that I have written for my simple reaction controller. And as you guys can see, this is linked with the iController class. And I have declared the required variables for random and GUI classes. Here I'm using an enum to create the machine states. And as you guys can see, that's extracted from the UML diagram. There are four states. This is the reset stage, which is also the ideal state of the machine. Then you have the waiting stage, and this is responding stage or the reaction stage. And this is the fourth stage, which is actually not mentioned in the program in the UML diagram, but this is the too soon state, and I will explain its specifications further in the program. Afterward, we have the current state, and this is basically a variable that's going to change as the program progresses. Tick count, this is basically used to measure the reaction time of the user, and the wait time is obviously as the name suggests, is going to calculate the waiting time. And afterward, the constructors and everything, you have the coin inserted function and the init function. So init function basically sets the display for the user to press go. And coin inserted function over here, as you guys can see, it resets the machine state into the ideal machine, and then it prompts the user to enter the coin into the machine. Afterwards, after the coin is inserted and go button is pressed, the machine enters into the go stop press function. And here, as you guys can see, we have the four mentioned states from the UML diagram, that is reset, waiting, responding, and too soon. In the reset state, let's say it says current state is equal to state dot waiting. So machine is in the waiting state, and tick count is basically 0. Afterwards, what happens is wait is time is equal to random get random. So yeah, over here, as you guys can see that the wait time is already set to about from 1 to 2.5 seconds, and this basically displays the wait here, state here, and So yeah, the reset state is basically displaying the wait characters over here, because the wait time is going to be between 1 to 2.5 seconds. So for that much time, so that's the waiting time that the machine has. And so reset state is basically helping the machine to display that. Afterwards, we have the waiting stage, and within the waiting stage, let's say if the user presses the go button too early, it's going to display too soon, because it's considered as cheating, as mentioned from the UML diagram. And the user has to wait for the machine to set again, so he or she can enter the coin and get the machine starting again. And afterwards, we have the responding state here. And this is the state that's going to display the measured time from the user. As 10 milliseconds is 1 second over here, it's mentioned. So yeah, the response time variable is going to get the calculations done and display the time to the user. And over here, the too soon state, as I mentioned earlier as well, it's basically going to reset the machine for the user to enter the coin again. Because if the button is pressed too early, it's considered cheating. And yeah, and then afterwards, we further get into the take function. And take function is basically what's helping the responding state to get the calculations done. As the machine enters into the waiting stage, the take count starts. And if it gets further or greater than wait time, uh, the machine is set into the waiting responding stage. And so yeah, it tells the user to enter, or sorry, press the button. And yeah, the reset state as well. So what I'll just do is start the program and display how the machine works. Here, simple reaction machine. So yeah, this is the machine, as you guys can see. And I'm going to press the insert coin button. It says coin inserted, press go. And the waiting time has started. And it starts calculating my reaction. And let's say that if I uh, react till 6 seconds. So yeah, so this is the reaction time that I have. And if I want to restart the machine again, I'm going to say insert coin again. And this time, let's say if I respond too early, as you can see. So the machine display that this is too early for the user to react. So it's the too soon stage. And I'll just get to insert coin again. Waiting stage. And yeah, get into waiting stage. Yeah. So this is how the program works. For the second part of this project, or the overall submission, what I had to do was uh, test the so yeah, a testing program was required in order to test the machine state and see if that works properly. And so I'll just display that now. Open project solution. SIT232. Just and so yeah, as you guys can see here, that this is the simple reaction controller testing project here. Over we have the tester class, then you have the random and controller class as well. Over here, the default program.cs, I had to comment it out because there were two classes with main function in each. So that had to be removed, obviously. And this is the simple reaction controller that we have. Over here, as you guys can see, that the variable names as well as machine state names have been changed. And the reason for that is that the tester class required certain syntax and certain words in order to pass the test properly. So I had to change those names. As you guys can see, the machine state names are changed from waiting to idle, ready, wait, run, and stop. Sorry. And Over here, certain changes have to be made in all the machine states in order to match the syntax so the test could be run properly. And what I will just do is explain how that works. Creation of two new variables was involved as well. So these are in, one is double and the other one is bool. First one is the last record time, and the other one is should display time. And so yeah, what I will just do now is run this program and explain. So you guys can see all the 38 tests have been passed. Earlier, I only got 34 out of 38 because of the different names and machine state uh, issues. But yeah, so this is my overall video demonstrations for SIT232 task, simple reaction control. Thank you.